to my channel. In this video tutorial, I am going to explain about the helix and spiral in the SolidWorks. To create the helix and spiral, we need the base circle here, and we'll practice the different options available in the helix and spiral. For this, go to top plane and normal, and create a base circle here. Provide the dimension. Now go to feature and select the helix and spiral. Now the input parameters you have to provide are the pitch, revolutions, constant and variable pitch, and options height and revolutions, height and pitch, and spiral. We will practice one by one. First of all, pitch and revolution. Now in parameters, select constant pitch and provide the pitch any value you want, 40, and the revolution, let's say 6, and the revolution clockwise, and start angle is 0 degree. You can change it to any value. Let's say 90, it starts from here, and if you select 0, it starts from here. Let's say it's 0 and click OK. Now go to front plane and normal. Now again go to helix and edit the feature. Drag this outward for the better visualization. Now we will try to change the parameters here. In pitch and revolution, pitch means from for one revolutions the height traveled. Here if you change the pitch to 20, you will see the decrease in the height of the output helix. So if you change it to the 90, it starts from here. Let's keep it 0. Now if you want height and revolution, now it gives you the idea of total height. That means from this point to this point is the total height, and in one revolutions the height gives the idea of pitch. That is height and revolution means you have to provide the total height from this point to this point, and in the revolution 6 you can change it. Let's change it to 4. The height remains same, pitch changes according to the revolutions. Let's say it's 8. Now the pitch changed here, the value decreased, but height remains same since we had chosen the height and revolution options. Again change it to the height and pitch. Now total height remains same, so let's say 130, and if you change the pitch to 20, the distance from this point to this point will increase. Let's see, click enter. But in case revolution changes, since the input is height and the pitch, in this way you can create the different types of helix as your requirements. Click OK. Now we will try to apply this in the real field. That means its application. For this we are going to create a circle and sweep it through this path. For this, let's input a plane here. Now first reference means this point, and in the second reference this line. Click OK and go to this plane normal and sketch a small circle here. Let's say diameter 5. Click OK, go to feature. You can select this circle take a sweat boss base command and path is a helix. Click OK. Now hide this plane. Now you can see the difference here in the real field test of the real view. For the better visualization, go to front plane and normal. Now if you go to the helix and change its parameters, suppose its pitch and revolution, and if the pitch is 30 and the revolution is 10, now click OK and it changes its shape according to the input value. In this way you can create the helix and uh, helix with the different input values. But here is another option also. In case of helix and spiral, you can see the spiral. What is a spiral? Go to edit the feature and select the spiral only. Now you can see the changes here. See the shape. This one is a spiral. As it comes outward, the diameter keeps increasing with respect to this point. Now again you can change the pitch. Let's say 25 or increase it to the 40, and number of revolution you can change. Let's say 2. Now only 2 revolutions. Let's change it to the 15. And if you click OK, then it creates the shape according to the input values. This one is the spiral. Now again go to edit features and select pitch and revolution. Go to front plane and normal for better visualization. Constant pitch. Let's say revolution only 5. Pitch is 25. Now we are going to practice the variable pitch option. In case of variable pitch, now you have to provide the different dimensions. Here you can see the revolution 0 and 15. Now if your pitch is varied to the 50 and the revolution varies, you have to provide the revolution from this point. That means the 15 revolutions are already here and your revolution starts from this point. So if you have to provide the 20, see there is a changes, and you provided the revolutions 20 and the piece 50. That means it automatically calculated the height. The diameter remains same in case of uh, in case of the variable pitch and revolution. Now again you can change the value to the 60 and so on. In this way you can see the variable pitch here. The pitch length is smaller here and greater here because the pitch keeps increasing or decreasing according to the input value. In this way you can practice the variable pitch. Let's select constant pitch again. There are many other options also. You can reverse the direction from the origin point. See the difference. You can change the number of revolutions, or you can select the clockwise or counterclockwise option. Now after practicing these options, Here is another option, tapered helix. Tapered helix means the angle changes with respect to the original drawing. Let's say the angle is 30. And click OK. It says that please enter the number greater than or equal to 0 and less than or equal to 11. Let's say 6. Taper out or in. You can see the changes here. Taper out means it goes taper towards this point, from this point. Tapered in. Let's click taper out. Click OK and go to front plane in normal for the better visualization. You can see there the helix is in tapered shape. In this way, there are many options. We have practiced almost all. You can always change the input parameters according to your requirements. This is the important feature in the SolidWorks, and it helps to create the many variable mm, drawings such as springs, variable springs, constant pitch, tapered springs, etc. Hope you understand the helix and spiral feature in the SolidWorks. If you like it, please subscribe and share this video. Thank you very much.